Hello students. In this lecture, we will discuss another question of Picard's method. In the last lecture, we have talked about the Picard's method and two questions. Now this is a different question. We have here solve dy by dx minus x minus y is equal to 0 with the initial conditions y at 0 is 1. We have to find the fourth approximation and use this to find y at 0.8. This means that you have to find the value of y at x is equal to 0.8. So let's see what we have here. So we know that x naught is 0, the initial point, y naught is 1 at that particular point. Now what is our f of xy? So we know here f of xy, our IVP is always in this form. dy by dx is equal to f of xy. So what is our fxy here? So consider the first order differential equation. We'll write it in this form, dy by dx is equal to x plus y. So here our x plus y would be the function. So this is our function f of xy. Now we'll start with our approximations. So the first approximation y1x would be equal to y naught plus the integral over x naught to x. In the inside of the integral, we have the function f of x y naught. Now since f of xy is x plus y, so in place of y we have to substitute y naught. Y naught is 1 as we know, so here our f of xy naught is x plus 1. So here under the integral sign we have 1 plus x, just integrate it and solve it. We got this as our answer. When we have applied limit from 0 to x, this is what we will get our first approximation. So y1 is 1 plus x square by 2. Now on the similar pattern, we'll calculate a second approximation using y1. Now in this formula, we have to first calculate what is f of x by 2. So this would be x plus y1, sorry. So here we have to calculate f of x y1. So this is x plus y1. Now putting the value of y1, we have this as 1 plus 2x plus x square by 2. So integrate it with respect to x, solve it, and we get the second approximation as 1 plus x square by 2 plus x cube by 6. Moving ahead with the third approximation, we'll be using our y2 x here. So let us calculate first f of x y2. This would be x plus y2. So we have to substitute this whole function here. So x plus 1 plus x square plus x cube by 6. So this would be 1 plus 2x plus x square plus x cube upon 6. So when we'll integrate this, we'll get this. Now apply the limits from 0 to x, and this is what we get our third approximation. So in this question, we have to solve up till fourth approximation. We have to find the fourth approximation. So when we put n is equal to 4 in the general formula, we'll get this. And let us calculate what is f of x y3. So this would be x plus y3. y3 we have calculated above. So this would be x plus 1 plus x square plus x raised to the power 4 upon 24. So this is our function f of x y3. When we'll put this value inside the integral sign, so we can solve it with respect to x, and when we'll apply the limits, this is what we get our y4. So this is our fourth approximation y4x. Now in the question it was given to us to find y at 0.8. So what is y at 0.8? How could we find it? Using, we have to find using the fourth approximation. So let us assume the fourth approximation to be as the equation 1. So in this equation, we have to put x is equal to 0.8. And when we'll substitute, we could easily find y at 0.8. So here is the value of y at 0.8, that is 2.64753. If we wish, we could find out its approximate value up to 3 places of decimal. So this would be 2.648. So this is our final answer. And in the next lecture, we'll be talking about the next method, that is Taylor series method.